Okay, now for the second part of 5.5, complex numbers. How do you do computations with complex numbers? First part we did adding, subtracting, multiplying. We also thought about what does I squared equal and what do other I values equal depending on the exponent. Okay, here's the four-step rotation that we had before, depending on what the exponent is. I equals I squared equals -1, I cubed equals -I, and I to the fourth equals 1. Dividing by 4, that exponent into 4, and seeing what the remainder is. Remainder 1, remainder 2, remainder of 3, or if it divides into it evenly. For this part, we're on do division. Okay, I said this one gets a little bigger, it's a little nasty of a problem to deal with, so make sure you have plenty of room when you're doing up these notes. Okay, so we're going to look at 3 plus I divided by 4 plus 2I. And the deal is you can't have an I in the denominator. So we're going to cancel that out, rationalize it, like we kind of rationalized the denominator in 5.3. Okay? The way we're going to do this is using the difference of a binomial. Okay? We're going to multiply by its conjugate. 4 plus 2I, we're going to multiply by 2I on the bottom. Now, we're multiplying 1 and multiply by 1. So if we're multiplying by 4 minus 2I on the bottom, we're going to multiply by 4 minus 2I up top as well. Because really that just means this would simplify to 1. Multiplying by 1 doesn't change that value. You get that value back. So we're changing what the value looks like, but not what the value actually is or the expression actually is. Now this is where you have a little bit of work. Okay? You have to multiply this through, and by taking your time, it's going to take a little bit of work. So doing the top first, good practice with multiplying here too. We're going to have 12 minus 6I plus 4I minus 2I squared. And that's going to simplify. Remember that I squared goes to -1, so this is actually going to be plus 2. And I have 14 minus 2I. I'm going to double check my work real quick. 12, -6I, 4I, -2I squared. Okay, I like that for the numerator. Now for the denominator, we're going to have, again, just doing the normal double distribute, 16 minus 8I plus 8I minus 4I squared. Now, look at our middle two terms. This is what we want to happen. This is what we need to happen. That's why I multiply by the conjugate. Those negative 8I and the positive 8I are going to cancel each other out. This I squared is going to -1, so this is actually plus 4. 16 plus 4 is 20. So we're left with 14 minus 2I over 20. Now, just like when we did the quadratic formula, if we have a fraction like this, kind of big and ugly looking, I would like you to break it down to two smaller fractions. We just don't have plus minus, it's just a minus sign in between, and simplify what you can simplify. Okay, so we have 14 over 20 gives us 7 over 10, minus 2 over 20 gives us 1/10, I over 10. If you wanted to write that as 7 minus I over 10, that's fine. Either one of those answers would be correct or acceptable. Another example here, 3 plus 2I divided by 4 minus 4I. So this time I'm going to divide top and bottom, multiply top and bottom by 4 plus 4I. So you're going to do the conjugate. It's the opposite sign. 4 plus 4I, 4 plus 4I. And again, the work to multiply it through does take a little bit of time. So be careful, watch your signs. Going through here, we're going to have 12 plus 12I plus 8I plus 8I squared. Simplifying this, we get 20I. Let's combine the like terms. 8I squared gives a -8, which then gives us 4 plus 20I. Now down below, we're hoping something cancels out. We're hoping all the I's cancel out. 16 plus 16I minus 16I minus 16I squared. So the middle terms we're good with. The middle terms cancel out those 16I's. This negative 16I squared goes to positive 16. So we're going to have 32 as our denominator. Now again, just like before, I'm going to break up smaller fractions. 4 over 32, so that's plus 20i over 32. Simplifying this, 4 over 32 goes to 1/8. Plus 20 over 32 goes to 5/8. So we have 5i over 8. If you would like to rewrite it, you can as one fraction. I'm going to leave it as 1 over 8 plus 5i over 8. This is a coincidence that both times we had 7 over 10 minus I over 10. Here we have 1 over 8 plus 5i over 8. It's not always going to work out where the denominator is going to be the same. It's nice when it does, but not always going to happen. Okay? Now I'm going to add one more type of problem here in this section, in this video. It's really just so you see it once, but it's nothing really any stranger than what we have been doing. When you have more than an I, more variables than an I, so in this case, 8x plus 9i plus 3x minus 2i, you're still just combining the like terms. You're still looking at this and saying, okay, 8x, 3x, they're like terms, so I'm going to add those. We get 11x. 9i plus a negative 2i gives me 7i. We still have a real number in front, imaginary number in the back. Okay, so those terms are no different. You still need to simplify the I if there's an exponent, so just make sure you're taking your time, watch your signs, combine the like terms. Okay. Do one last example. Just a real big one so you can see that it is possible to do. Now this time we're going to have to do distribute terms where the variables, there's two variables in one term. If we're distributing this 6x squared, okay, let's see what we're going to get. 36 x squared I to the 5th plus 30 x cubed I plus 18 x cubed. Let's rewrite minus 6i to the 6 plus 8x cubed. Now what I'm going to do here, I'm going to go through and simplify all my i's. Okay, I'm going to simplify. I'm using this 4-step rotation and just think about how can I to the 5th be simplified, I to the 6th, and fix this up a little bit. So I to the 5th, divide by 4, there's a remainder of 1, so that's not simplified just to I. 36x squared I. The 30x cubed I, I'm just going to bring down. The 18x cubed, I'm just bringing down. The negative 7i to the 6, divide by 4, remainder of 2. So that's how simplified to negative 1. So that 7 is going to become a positive 7. And I'm going to bring down the plus 8x cubed. And now I'm going to look at this and just see what can I combine and what like terms are and where do they have to be. Real numbers in front, imaginary numbers in back. So 18x cubed, 8x cubed, that's going to give me 26x cubed. I'm going to bring down the 7. So there's my real numbers. Imaginary numbers plus 30x cubed I plus 36x squared I. And there's no more like terms. Both the variables and both the exponents for both variables need to be the same. So even though they both have i's here, I can't combine them because that's x cubed and that's x squared. There's no more like terms, so that would be our final answer. Okay? You're going to have to find, I mean, some of these get kind of nasty. You have to multiply through and look at what you can simplify. Simplify things so you get down the variables to see what the real like terms are. Okay? So that's section 5.5, computations with complex numbers.